Here's an example using the TI-84 Plus calculator to get cubic models. So here you're given a data set. The table shows UN data from 1975 and projections to 2050 of the size of the country's labor pool, ages 15 to 59. So here they're giving you years from 1975 to 2050. And then here they're giving you the labor pool in millions. So this represents X values, this represents Y's. So part A, find the cubic function that best models this population as a function of the number of years after 1970. Let X represent the number of years after 1970, and let Y represent the number of millions of people in this labor pool. Report the model with three coefficients, rounded to 3 significant digits. So I already have the model here, but I'm going to go ahead and show you how to get it. So X represents the number of years after 1970. So this X value that corresponds to the year 1975 would actually be 5, because 1975 is 5 years after 1970. So X value here is 5, 10, 15, 20, 25, and so on. So to enter your data, you always press the Stat button. I always like to use List 1 and List 2, and that's what I recommend that you do. So open the Edit menu, press Enter. Now actually, for time's sake, I have the data listed. But just to show you really quickly how to do it, let's say I go up here and I press Delete, which is something you don't want to do. You always want to press Clear. But let's say I accidentally delete List 1. How to get it back? It's super easy. Press the Stat button. Go to option 5, press Enter, and then your list should be back right there. So you go up here. If you want to get rid of the data in a list, you clear it out and go down. And so to enter your data, you simply just enter it 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, and 80. And so we have our data listed here. You should have the same amount here of X's and same amount of Y's. We have 16 of each. And so to get your cubic model, you go to the Stat button, right arrow over to Calculate, and go down to Cubic. Option 6, Cubic Regression. Press Enter. And it's going to have List 1, List 2, Frequency List, and Store Regression EQ. You leave these two alone. And that's why I said it's always easiest to use List 1 and List 2. You don't ever have to change these. But let's say you did use List 3. You can clear this out and change it to List 3 by pressing second. And see here, L3, you would press second 3, and it would bring up List 3. But I'm going to go ahead and put back List 1, so second, number 1. And those you shouldn't have to change if you always use List 1 and List 2. Press Calculate by pressing Enter, and it's going to give you the model. So A, B, C, and D are the coefficients of this model. And so they want you to round to 3 significant digits. And so significant digits, or I'm not going to go into a lot of detail here. I'm going to attach another video about significant digits. But basically, looking at this first number here, 2.08, rounding to 3 numbers, it would be 2.09, right? Because this 0 is significant because it's between 2 non-zero digits, right? E-4. This E-4, it's scientific notation. And what that means is you have to shift your decimal 4 places to the left. So that puts 3 zeros, 1, 2, 3 zeros in front of the 2.09. So the number in front of x cubed ends up being 0.000209 x cubed minus, and then 3 significant digits, we have 1, 2, and then this becomes a 1. That's 3 significant digits, plus 22.8x plus 365, rounding to 3 significant digits. All non-zero numbers are always considered a significant digit. And so here, this is the cubic model that you get. So part B, graph the model and the data on the same axes and comment on the fit. So we're going to go ahead and graph it. So to graph it, what you need to do is first turn on your stat plot. So go to y equals and go up here and just highlight plot 1 and press enter. And that's going to turn on your stat plot. Basically, it's going to graph these little dots here for you. And now we're going to enter the equation so it can graph the model for us. So x raised to the third power minus 0.251 x raised to the second power plus 22.8x plus 365. Okay, and then of course you have to change your window settings to what they want. So the windows, your x's are from 0 to 80 with a scale of 5. So from 0 to 80 with a scale of 5. So your minimum is 0, your maximum is 80, and you have an x scale of 5. And then your y's from 0 to 1,000 with a scale of 100. And then you go ahead and graph it. And you see the graph here. This is part of the model, and that's the data. And so use this model to predict the size of the labor pool in 2026. Use this model that we got up here, this cubic model, to predict what the size of the labor pool in the year 2026. Well, the x value that corresponds to the year 2026, what you're looking for is basically subtracting off 1970, because x represents the number of years after 1970. So 2026 minus 1970, your x value here is actually 56, right? So to use the model, the x value is 56. So you replace, everywhere you see x, you replace that with 56. So I'm going to go ahead and just clear this out. And I'm going to input x into the model. And that's going to give me the predicted value. And so you end up with 891.36 and so on. And so we're going to round. And so the size of the labor pool is about 891 million. So the last part, according to the model, when is the labor pool projected to be at a maximum? So that's somewhere up here. The calculator can find that for us. If you go back to the graph, right, and you press second, it says calculate right here. Second, trace. You press the trace button, and you're trying to find a maximum, so you go down to the fourth option, press enter, and then your maximum is somewhere about right here. So the calculator is asking for a left bound. So basically, you move your cursor to the left or to the right, and so you want to be to the left of this maximum. So just come somewhere over here. Make sure you're to the left of the highest value here that you see on the screen. Press enter, that's a left bound. And then a right bound, you come and you move your cursor to the right, And you want to be somewhere to the right of that maximum. So over here, press enter. And then press enter one more time. And so maximum is 48 is the X value, and 904 is the Y value. Well, the X value, 48, they actually want the year here. The maximum will occur in the year 2018 because remember, X represents the number of years after 1970. So 1970 plus 48, that will be 2018. So the maximum will occur in the year 2018, and during that year, the labor pool will be comes from the Y value, 904 million. And so that's it for this video.